First is multispectral imaging. Multispectral imaging using discrete detectors and scanning motions. So basically, this is where satellite is flying from um, these directions. The camera have a scanning mirror to rotate the sensor so that it scan left and right. So this is the scanning mirror motion. Landsat MS, TM, ETM, GOES, AVHRR, and CWIPes are the representative in this category. So Landsat emission have a very long history since the early Landsat 1 launched in 1972 that started the legendary civil application of satellite sensors. So as of today, it has launched Landsat 9 in September 2021. It is known that Landsat 7 have 40 scan line arrow after 2003. So this is how the 40 line scan line arrow look like. Basically, there are certain detector cameras stop working, so it's not recording any information. Typically, I will instruct my student not to use data set like this. So this is an example to compare the spatial resolution, the spectral band, and spatial resolution for different Landsat missions. So Landsat 45 TM is one that is more frequently used. So as you can see that they have 30-meter resolution and thermal band have 120, and then ETM have 30, but thermal improved to 6-meter resolution. And the panchromatic is 15-meter resolution. So as you can see that from Landsat 7, they start to offer panchromatic band. And then if you look at Landsat orbit, this is a very classic representative one that you are repeatedly seeing the same parameters from other missions. So Landsat is the representative of sun synchronous orbit. What it means is that the satellite crosses the equator at the same local sunlight with each orbit. So that way, it provides a very uniformity of light conditions. So you don't have to worry too much about the calibration to minimize the sunlight illumination condition in different images. So the satellite orbit the Earth in this kind of motion. Meanwhile, the Earth is rotating along these directions. So if you look at this track of the Landsat data, will look like this. So look at the mechanism, how MS to acquire data set from the Earth. So when the sensor is orbit Earth along this direction, perpendicularly, the mirror will control the light to scan left and right to scan the Earth in the perpendicular direction. So the camera will scan this one line and retrace and then scan another line. So that is how these kind of scanning mirror system work. And if you compare Landsat MS and Landsat TM, take a look at the orbit information. It's very typical 705 for Landsat TM, 98.2 degree inclination, and 16 days of revisit time, and 30-meter resolution. Thermal band will be 120. So this is a comparison of different spectral band. And then Landsat TM is one used quite often during those period of time from launch from 1984 to November 2011. So it has this kind of optical mechanical whisk-broom sensor system. So this is how the satellite work. You have a solar array system, the antenna for transmitting data set, and the GPS position, and the camera is located somewhere over there. And then they have this attitude control module and power module on this sensor. So you can take a look at individual band in grayscale, and that is how the image may look like. And thermal band always have much coarser resolution. If you look at this feature over here, you will notice that this is much darker in this two bands, but then much brighter in this one and other ones. So similar difference that you observe in different bands is very helpful for us to differentiate different light cover types on the image. Let's take a look at specific band information so we know which band is suitable for what kind of application. take this example for Landsat TM. The band 1 is the blue band. Blue band is the shortest wavelength band. So therefore, they have very good water penetration, and which means that typically when you look at the image, you will get more texture in the area with shallow water. And it's good for differentiating soil and rock different surfaces from vegetation and smoke plumes, and also very sensitive to atmosphere haze because it's the one with the shortest wavelength, with similar size to the particle in the atmosphere or haze. Band 2 is the green band, which is good for water turbidity difference mapping, sediment and pollution plumes, and also discrimination of broad class of vegetation. Band 3 is red, has strong chlorophyll absorption, so it's good for differentiating vegetation via soil, urban versus rural areas. Band 4 is the near infrared. It's good for differentiating different vegetation varieties and conditions, dry versus moist soil, coastal wetlands, swamp, or flooded areas. And then band 5 is a near infrared, longer near infrared band. So it's sensitive to leaf tissue water content, soil moisture, snow, and versus cloud discrimination. Band 6 is a thermal band, basically good for heat mapping applications. A lot of people use this thermal band from Landsat for urban heat island analysis. And then radiometric surface temperature ranging, and band 7 is the near infrared, much longer near infrared. So it's the band with great absorption by hydrous minerals like clay, mica, or some other clay zone mapping. So this is Landsat 7. It has 7 spectral bands, and also from visible to infrared, and also have one thermal band. So this is how individual band look like from the data set. You may be curious about how image is being acquired in this kind of digital sensor. And this is example for Landsat 7, how the digital detector work on this image. So typically you have these multispectral images with the same size, which is with the 30-meter spatial resolution. And then the thermal band have much larger, so therefore much coarser spatial resolution. And the panchromatic band is the one with 50-meter resolution. So as you can see that they have much smaller detector to map, to sample, and also much more number of detectors to sample the ground, hence higher spatial resolution. So this gives you a general idea about how the digital camera chip may look like. This slide shows the example of individual band from Landsat dataset. To work with remote sensing images, sometimes you may observe these kind of artificial lines in the image, knowing that usually in the natural ground system, we don't really have this kind of straight line in the dataset. So this is a common phenomenon called detector failure. So just be mindful about this existence of this failure. And sometimes what the mission does is they will fill these pixels with relatively high number on the image, high pixel values, so that you will know that it's arrow sensors, like an arrow in those locations. Earth Observer EO1 is launched on November 1st, 2000 by NASA. So it has the same 705 kilometer sun synchronous orbit as Landsat at a 98.7 inclination. That is just flying 1 minute behind Landsat. So if you ever run into problem from the Landsat dataset, EO1 is another source you can check with data with similar characteristic parameters. This is comparison of Landsat TM, ETM, Enhanced TM Map Plus, Thematic Mapper Plus, Landsat ETM versus EO. So you will see that they have very similar 705 16 days and satellite parameters. And they also have 30-meter resolution, but have slightly more bands than the Landsat is. So EO1 can be one of the complementary data set for Landsat. Another representative is the geodetic orbiting Earth satellite, GOES. So the GOES system use geosynchronous satellites, which since the launch of the mission from 1974 has been a basic element of US weather monitoring and forecasting. So this diagram shows that the satellite is basically appear to be fixed over one spot above the equator. So this GOES dataset obtain image of clouds, monitor surface temperature and water vapor characteristic, and sound the Earth's atmosphere for its vertical thermal and water vapor structure. So this is data source that you often see on the weather report and track of hurricane and other informations. So this is how the dataset, the track, the observation coverage of these two satellite sensors and how the image may look like. So these are the typical data set from this image. Quite often we see similar image from news report. So that may indicate that the data set may be coming from this sensor. And then the advanced very high resolution radiometer, AVHRR, launched in 1978, just 6 years after the first Landsat mission. They have this polar orbiting, which means that they will orbit the Earth in this kind of polar region and circle the globe twice a day from an altitude of 833 kilometers. So basically the temporal resolution is about half day. The image cover a much larger area and have a 1.1 kilometer resolution. The 1.1 kilometer resolution is typical resolution for global studies level. It collects data from these kind of 0.58 μm to 0.12, 0.50 μm, which divides into 5 band. So this is an example how the surface temperature from the sensor look like. And then this is specific wavelength and its use. So this is example band 1, 2, 3, 4, and 5. Example of individual band image. And this is a list of low to no cost satellite sensors and data streams utilized for land surface phenomenon studies. So as you can see that AVHRR, MSS, TM, vegetation spot image, and then MODIS dataset. So most frequently people use Landsat and MODIS dataset for some city to regional scale of studies.